Hello everyone. In this video we are going to discuss about some problems on properties of the system. And we all know the properties of systems are linearity, time invariant, memoryless, casual and stable, as well as invertibility. And in today's problem we are going to discuss whether the system is linear, time invariant, memoryless, casual and stable. And for that we are having a system y of n is equal to x of 2n. For this system we are going to check these 5 properties. Okay, let us start solving this problem. The very first property is linearity. Let us take linearity. Linearity is the system which obeys a superposition theorem, right? For that, let us consider y of n is equal to operator h of x of n. Let us consider y of n is equal to h of x of n, which is equal to x of 2n for the given problem. Y of n is x of 2n, which can also be written as h of x of n, operator h. Okay. Therefore, h of a into x1 of n plus b into x2 of n will become, since h of x of n is x of 2n, then h of a x1 of n plus b x2 of n will be a1 x1 of 2n plus, sorry, this is a x1 of 2n plus b x2 of 2n. The place of x of 2n we are replacing by a x1 of n plus b x2 of n, whereas x of n is nothing but x of 2n. Therefore, we are replacing x1 of n by x1 of 2n and x2 of n by x2 of 2n. Okay. A is constant, keeping as it is. X of 2n is h of x of n. Therefore, x1 of 2n will be h of x1 of n plus, since b is constant, keeping as it is, x of 2n is h of x of n, whereas x2 of 2n will be h of x2 of n. On the LHS, h of a x1 of n plus b into x2 of n. Since comparing LHS and RHS, the property of superposition holds good. Therefore, the system is linear. Comparing LHS and RHS, the superposition theorem holds good, hence the system is linear. Okay, let us move on to the second property. Moving on to the second property, time invariance. Okay, and time invariance, as we all know, y of n is equal to x of 2n, and we marked it as h of x of n is equal to x of 2n, right? We marked it like this. And now for time invariance, h of x of n minus n naught, we need to find h of x of n minus n naught. Okay, time shifting 1 minus n naught is added. Therefore, in the place of x of n we are replacing it by x of n minus n naught. Therefore, here it becomes x of 2n minus n naught. In the place of x of n minus n, x of 2n, sorry, x of n, we are replacing it by x of n minus n naught. Therefore, x of 2n becomes x of 2n minus n naught, and for the output y of n minus n naught, for the given output y of n is equal to x of 2n, if I replace n by n minus n naught, it becomes x of 2 n minus n naught. Okay, now I am replacing n by n minus n naught, therefore here also n is replaced by n minus n naught. By comparing these two equations, I can say y of n minus n naught is equal to h of x of n minus n naught, right? By comparing these two equations, I can write it as y of n minus n naught as h of x of n minus n naught. Therefore, the system is time invariant. If you want to look at the properties of the system, please go back to the previous videos where I have discussed about the properties of the system. Please do go cross verify with the properties, linearity, time invariance, okay, memory, causality and stability, as well as invertibility, so that these concepts will easily understandable. Okay, this is about the second property, time invariance, and the third property is memory. The given system is y of n is equal to x of 2n. Okay, let n is equal to 1. Let us substitute n is equal to 1. The given expression becomes y of 1 is equal to x of 2 times 1, right? Which is nothing but y of 1 is equal to x of 2. For the present output, the input is at the next step. For y of 1 output, the input is at the next input is taken into consideration. Since the present output at 1 second, y of 1 second is taking the input of x of the second. Therefore, the present output depends on the future input. The present output depending on the future input. The system is memory, is having, the system is having memory. Since the present output depending on the future input, the system is having memory. Okay, and the fourth property is causal. As we discussed in the previous video, since the present output depending on the future input, since the present output depends on future input, the system is not causal. The system is not causal. Again, I am saying, please do go back to the previous video to know about the properties of the system. When the system is called as a memory system, when the system is called as a causal system, please do go back to the previous video, which is named as properties of the system, so that you will understand these properties very clearly. Okay, and the last property is stability. The last property is whether the system is stable or not. Okay. Let mod of x of n is less than or equal to bx, which means x of n is bounded by a value bx which is less than or equal to bx, then mod of y of n, which is nothing but mod of x of 2n, is also bounded by a value by. Since x of n is bounded by a value bx, the value of output y of n, which is nothing but x of 2n, is also bounded by a value by, then the system is said to be stable. If the output y of n is not bounded by a value by for a bounded input, then the system is called as an unstable system. Since for a given input x of n bounded by a value by, the output y of n is also bounded by a value by, the system is said to be stable system. Okay, this is about the properties. Okay, let us move on to the second problem so that we can understand it even more clearly. Let us consider one more problem. Determine whether the signal y of n is equal to summation of k is equal to minus infinity to n x of k plus 2 is linear, time invariant, memoryless, casual and stable. We need to check whether this system holds these properties or not. Okay, let us start with the first property, linear. First property is linearity. Let y of n is equal to h of x of n. Let y of n is equal to h of x of n, which is nothing but summation of k is equal to minus infinity to n x of k plus 2, right? This is the given equation. Now for linearity, h of a x1 of n plus b into x2 of n. We need to check what is the resultant of h of a x1 of n plus b x2 of n, which is equal to, since h of x of n is summation of k is equal to minus infinity to n x of k plus 2, h of a x1 of n plus b x2 of n will be equal to summation of k is equal to minus infinity to n. In the place of x of k plus 2, we will be writing a x1 of k plus 2 plus b x2 of k plus 2. In the place of x of k plus 2, in the place of x of n, we replace it by a x1 of n plus b x2 of n. Therefore, in the place of x of k plus 2, we are replacing it by a x1 of k plus 2 plus b x2 of k plus 2. That will be equal to summation of k is equal to minus infinity to n. Summation into the first term will be a x1 of k plus 2 plus summation into the second term will be summation of k is equal to minus infinity to n b x2 of k plus 2. Okay. Now on rearranging, since a and b are constant, we can keep them outside the summation. Therefore, a into summation of k is equal to minus infinity to n x1 of k plus 2 plus b into summation of k is equal to minus infinity to n x2 of k plus 2. Okay. By comparing these equation with the first equation, summation of k is equal to minus infinity to n x of k plus 2 is marked as h of x of n. Therefore, a into this first term can be compared with this one, where x of k plus 2 is marked as x of n. x1 of k plus 2 can be marked as h of x1 of n. Similarly, b into h of x2 of n. And the LHS, h of a x1 of n plus b into x2 of n is equal to a times h of x1 of n plus b times h of x2 of n. Therefore, the system is linear. Therefore, the system is linear. Okay, this is about the first property. Now, we'll be moving to the second property. The second property is time invariance. Let us start with the second property, time invariance. Okay. For that, we need to shift the time. H of x of n minus n naught will be equal to, before that we need to define x of n is equal to summation of k is equal to minus infinity to n x of k plus 2, which we marked it as h of x of n, right? Now, for time invariance, we need to shift the time. H of x of n minus n naught, in the place of x of n, we are replacing it by x of n minus n naught. Therefore, this expression will become summation of k is equal to minus infinity to n. Remember, we are only replacing x of n by x of n minus n naught. Wherever we find x of n, we need to replace it by x of n minus n naught. K is equal to minus infinity to n. X of, in the place of n, we are having k plus 2 minus n naught. Okay. X of n minus n naught. X of n is replaced by x of n minus n naught. Therefore, x of k plus 2 is replaced by x of k plus 2 minus n naught. And now, for y of n minus n naught, here we replaced x of n by x of n minus n naught, whereas here we are replacing by y of n by n minus n naught. We are only replacing n terms. In the place of n, we are replacing it by n minus n naught. Wherever we find n terms, we need to replace it by n minus n naught. Summation of k is equal to minus infinity to n. In the place of n, we are replacing it by n minus n naught. Here, n minus n naught. Okay. Into x of, here we don't find any n terms, marked as k plus 2. Okay. In the first step, we replace the whole x of n by x of n minus n naught, whereas in the second step, we are replacing only the n terms, not the x terms. Okay. Now we got the summation as k is equal to minus infinity to n minus n naught. On rearranging the terms, summing terms, we'll get k is equal to minus infinity to n x of k plus 2 minus n naught. Okay, on rearranging the terms, we'll be getting this expression, which is very much similar to that of our the first term. Therefore, h of x of n minus n naught is equal to y of n minus n naught. Hence, the system is time invariance. Hence, the system is time invariant. This is about the second property, time invariance. Let us move on to the third one, memory. The given expression is y of n is equal to summation of k is equal to minus infinity to n x of k plus 2, right? Let us assume the value of n is 3. For time being, we are assuming the value of n is 3. You may assume 2, you may assume 4, whatever the value you can choose. Okay, I am assuming n is equal to 3. Now, y of 3 the output at time 3 is equal to, okay, I'm splitting the summing point now, x of the k value at the first step is minus infinity, x of minus infinity, plus 2 is again minus infinity, x of minus infinity, plus if we keep on moving at some state we will be getting at k is equal to minus infinity, it is varying till n is equal to 3, and I will assume it at minus 4, k is at minus 4 now. It becomes x of minus 4 plus 2 is minus 2 plus at k is equal to minus 3. Minus 3 plus 2 is minus 1, and at k is equal to minus 2, it becomes minus 2 plus 2 is x of minus 1, x of 0, plus at k is equal to 0, at k is equal to 0, x of 0 plus 2 is, sorry, at k is equal to minus 1, right? After minus 2 it is minus 1. Minus 1 plus 2 is 1, plus at k is equal to 0, 0 plus 2 is x of 2, right? Now we got for output at time interval 3, are you people getting? If we put k is equal to, if I substitute k is equal to 1, it becomes 1 plus 2 is 3, right? Output at a time interval 3 is not only depending on the present input at x of 3, it is also depending on the past inputs, right, as well as the future inputs. If you keep on applying, if I put k is equal to 2, x of 2 plus, since k varies till 3, as I substituted n is equal to 3, k varies till 3. If I put k is equal to 2, 2 plus 2 is x of 4. The output at time interval 3 does not depends only on the present input, it is also depending on the past inputs as well as the future input. Hence, the system is having memory. Hence, the system is having memory. Okay. And the next property is fourth one, casual. As we discussed in the previous step itself, since the present output not only depends on the present input, it also depends on the past inputs as well as the future inputs. Since the present output depends on future inputs, the system is not causal. Since the present output depends on the future inputs, the system is not a causal system. Okay. And the last property is stability, property number 5. Stability. Let the input x of n is bounded by a value bx. Okay. Let the input x of n is bounded by a value bx. Then, if the output y of n, which is equal to mod of summation of k is equal to minus infinity to n, x of k plus 2 is also bounded by a value by for a given bounded input. If the output is also bounded by a value by, then the system is stable. I'm repeating again. For a given input, for a given bounded input bx, the output y of n is also bounded by a value by, then the system is said to be a stable system. Okay. This is about the second problem. Y of n is equal to summation of k is equal to minus infinity to n x of k plus 2. To understand even more clearly, let us consider one more problem. The problem is like this. Determine whether the signal y of t is equal to d by dt e power minus t x of t is linear, time invariant, memoryless, casual and stable. The previous two problems were with respect to discrete time signals, whereas this present problem is with respect to continuous time signal. Okay, people can go back and check. In the previous problem it was y of n and now it is y of t. Whenever t comes, it is with respect to continuous time signal. Okay, let us start the problem. First property is linearity. Okay, for that let y of t is equal to h of x of t, which is equal to d by dt e power minus t into x of t. Okay, d by dt e power minus t into x of t. Then for linearity, h of a x1 of t plus b into x2 of t, a x1 of t plus b x2 of t can be written as, since h of x of t is d by dt into e power minus t x of t, h of a x1 of t plus b x2 of t will be d by dt into e power minus t. X of t is replaced by a x1 of t plus b x2 of t. We are replacing it by a x1 of t plus b x2 of t. Okay. On splitting, d by dt e power minus t a into x1 of t plus e power minus t b into x2 of t. Okay. Since we can say d by dt of a plus b can be written as d by dt of a plus d by dt of b, we can split it by d by dt e power minus t a into x1 of t plus d by dt e power minus t b x2 of t. Since a and b are constants, we can keep it outside the differentiator. A into d by dt e power minus t into x1 of t plus b is constant, keeping it outside, d by dt e power minus t x2 of t. Okay. Comparing this expression with the given expression, d by dt of e power minus t into x of t is marked as h of x of t, whereas d by dt into e power minus t into x1 of t can be marked as h of x1 of t. Since it was x of t, it was h of x of t. Since here it is x1 of t, we can mark it as h of x1 of t, plus similarly here b into h of x2 of t. On the LHS, it is h of ax1 of t plus bx2 of t is equal to a times h1 of h of x1 of t plus b times h of x2 of t. Therefore, the system is linear, since it obeys the property of superposition. We can say the system is linear. Okay. And the next property is time invariance. Let us move on to the second property. time invariance. Moving on to time invariance, we need to define the given input y of t is equal to d by dt e power minus t into x of t, which is nothing but h of x of t. For time invariance, h of x of t is replaced by h of x of t minus t naught. The whole x of t is replaced by x of t minus t naught. Therefore, d by dt, we need to replace x of t terms by x of t minus t naught. E power minus t, x of t is replaced by x of t minus t naught. Here we are replacing x of t by x of t minus t naught. Therefore, only the x of t terms are replaced by x of t minus t naught. And secondly, y of t minus t naught. Remember, here we are not looking at x of t, we are looking at the t terms. T term is replaced by t minus t naught. Therefore, d by dt of e power minus t minus t naught into x of t minus t naught. Wherever the t terms comes, e power minus t is replaced by t minus t naught and x of t is replaced by t minus t naught. Comparing these two equations, y of t minus t naught is not equal to h of x of t minus t naught. Therefore, the system is not time invariant. Hence, the system is not a time invariant system. Okay. If these two terms are one and the same, then the system is called as a time invariant. Since here y of t minus t naught is not equal to h of x of t minus t naught, the system is not a time invariant system. Move on to the third property, memory. Since the differentiator has memory, since the given output y of t is d by dt of e power minus t into x of t, which comes under the differentiator, and the differentiator has memory, therefore the system is having memory. And the fourth property is casual. Since the output doesn't depends on the future inputs, the system is casual. Since the output doesn't depend on the future inputs, the system is casual. And the last property is stability. The last property is stability. If we assume x of t, the input x of t is bounded by a value bx. If we assume x of t is bounded by a value bx, then y of t is equal to mod of d by dt e power minus t into x of t is bounded by a value by. Okay, since x of t is bounded by a value bx, the differentiation of x of t is also bounded by a value by. Therefore, the system is stable. Okay. For a bounded input, the output is bounded by a value by, hence therefore the system is stable. If you people have any doubts, please do message on my comment box. We'll be connected. Thank you.